it's running, so you can just try to hold it as steady as you can. And you can put me right here, that'll be fine. Good morning to those of you who are here this morning. We want to thank you for being here. My wife has been away for 10 weeks doing research in the lab at the National Science Foundation, granted her a scholarship at Bigelow Laboratories to do some research. And she's here this morning to present what she discovered in the 10 weeks she's been away. And so she's been working very hard on her discovery. And I believe that she has something to tell us and show us about a level we never thought about, which is the micro level of the world, of our society, of the earth itself. To know there's another dimension beyond the physical that we don't see with the natural eye. So this morning, give her as much time as possible to present that. Here's my wife from Bigelow Laboratory present her research for this summer 2016. Thank you. Deputy Peart.
Thank you. Like Gary said, I was given the opportunity to do some research, and
Thank you, ma'am.
I'll just get right into it. So here we are at Chestnut Assemblies of God in Vineland, New Jersey, and just to give you a perspective of where I went this summer, here's South Jersey and Vineland right where we're at, and I traveled 494 miles up to this little town called Boothbay, Maine. And just to give you an idea, it is a very different type of place. Vineland is a metropolis compared to Boothbay, Maine. And up in Boothbay, I was invited to go to Bigelow Laboratories for Ocean Sciences, and here I was given a mentor, or the mentor decided to choose me to help her with the project that she was given this summer. And the question that she was given this summer was to see just how much microplastics are we ingesting when we eat seafood. And this is my mentor's name, Patricia Matrai. And we weren't the only ones working on this question. We had a lot of help from these individuals, that this project couldn't be done without them. But in all honesty and in all fairness to this question, my mentor said that she couldn't answer this question directly without first looking at a different question: microplastics and nanoplastics in the marine microbial food web. And just to give you an idea or some background information, what are microplastics? If I say the word plastic, all you have to do is look around and you see plastic everywhere. We function with plastic. But when I say the word microplastic, it's defined as anything smaller than 5 millimeters. And for those of us who are not into the metric system, if you take out a penny, the word liberty is exactly 5 millimeters long. So every time you look at a penny now, you see the word liberty, that's 5 millimeters. So I'm talking about plastics that are the size or the length of the word liberty and smaller. And there's two types of microplastics categorized as either primary and secondary. Primary microplastics are those that are found in cosmetics products, such as the microbeads, facial scrubs, and toothpaste. And then the secondary microplastics, they're generally from fragmentation, so when larger plastics get broken down into smaller pieces. Those are the secondary microplastics. And then just to further define the primary microplastics, there's this word called nurdles, which just is a really funny word to me. But nurdles we're actually more used to in our everyday life than we realize. Nurdles are these spherical shaped microplastic beads that are used in a lot of different products. Like in my little shark here, if you feel the beads, those are the nurdles. And they are used in very common everyday products, such as the pillows that we use, like when you go traveling. So anytime you feel those round beads in any products, those are nurdle microplastics. And then another type of microplastic, primary microplastics, so these were produced, they were manufactured for this specific size, are the microbeads. And that's what we see in cosmetics as well as in toothpaste. And one of my lovely tasks this summer was to take Crest toothpaste and get the plastic out of it.
Wow.
That's
So
in your
I'll
toothpaste.
pass this around.
Wow.
I don't recommend doing it at home unless you have a lot of time on
That's
your
plastic
hands.
in your toothpaste.
In the plastic
Right.
toothpaste that we use.
So like Gary said, he always thought it was just crystals, but it's actually another type of plastic.
Yeah.
And the purpose why they were put in there was to be an abrasive. And then, so going back really quickly to the secondary microplastics, there's two types. There's fragmentations, which I mentioned earlier about larger plastics being broken down, or broken up into smaller plastics, but also fibers. So in our clothing, every time you wash your clothes, if you have nylon pantyhoses, if you have fleeces, there it's a synthetic plastic in our clothing that actually come off as these little tiny
balls.
pieces. Yeah.
Yeah.
And they're often under the microscope look like little strings of fibers. And so, like, yes, they're very much from laundry. And every time you wash your clothes, if you have synthetic clothes, you're releasing microplastics.
Wow.
And so, one of the big questions, why do we even care about microplastics? We can't really see them.
No.
But what we're discovering more and more is that they are in the environment. And when it's in the environment, we want to know what's going on with them and how they're impacting our lives and our future. We're becoming more aware of their increasing abundance. So as we've started to study this, other scientists have started to study it, we're starting to see more and more microplastics. And then also, it's important because plastics don't really biodegrade. So that means they never go away. So what's going to happen to them? And then we have seen them eaten by animals. There's a lot of very sad pictures of what happens to animals when they ingest them. It's just not good for them. And then also, toxins absorb or stick to the surface of the plastics, as well as different manufacturers for different purposes use different additives that could be potentially toxic to the environment as well as to ourselves.
Wow.
And so at Bigelow, why we focus on the microbial rather than the large plastics is because Bigelow's mission is to investigate the microbial drivers of ocean or global ocean processes through basic and applied research, education, and enterprise. And so basically what that means is instead of looking at the big stuff, they want to look at the small stuff. And so because of that word microbial, that's why my mentor and myself were given the task to look at the microbial or microplastics. And this is a cartoon that I really like to emphasize the point. We're all kind of familiar that the small fish is eaten by the big fish, by the bigger fish, and eaten by the bigger fish, and by the bigger fish, by the bigger fish, and ultimately by the bigger fish, and then ultimately us because we eat the big fish.
And then we all know.
Yeah.
Mm-hmm.
And so when it says, darn, I don't like those green ones, this cartoon's really saying that even though we might be eating the big yellow fish, we're still impacted by the little ones. The little ones. And so another way of looking at this is from the pyramid. This is a very simple cartoon of the pyramid of the shark at the top, so the big fish, and he eats the smaller fish, and they eat the smaller fish, and these smaller fish will eat the crustaceans or the crabs, lobsters, etc. And all of these guys eat the even tinier stuff, the microscopic,
scrape the wall,
the phytoplankton. And so this is where my study started, was right here at this base level of the phytoplankton. And just to give you a little bit clear understanding, so the word micro comes from, or has a similar base of microscopic. And microscopic just means you need a microscope to see it. So it's really tiny stuff that you need a microscope to see it. And so in this other food chain diagram, I was working with the phytoplankton, and phytoplankton are defined as consisting of microscopic plants. So instead of little animals, I was looking at the little plants that float in the ocean that impact our lives in a huge way. It's estimated that 50% of the oxygen that we breathe actually come from these little plants that are in the ocean, not just from the trees on land. And so I was working, here's a picture of the 3 species of phytoplankton that I was working with. They're all single cell, which is kind of hard to fathom sometimes, that this whole living organism is just one cell. there was 3 that I was working on. And so the question that I was given was, do microplastics impact phytoplankton growth? So those that grow plants, you know that plants need certain nutrients, and
Yeah.
certain things will help them grow versus certain things will stop them from growing well. So my little plants in the ocean, I wanted to see what's happening if I put microplastics with them.
Right.
And then so from this main question, 3 sub-questions came out of it. Does the concentration of microplastics matter? And then does the type of microplastic matter? And then also, are different types of phytoplankton impacted the same way? As you saw in this one, I was using 3 different species
Right.
and 3 different types of phytoplankton. So were they all gonna have the same impact? And so my setup, I had 3 different types of plastics: polystyrene, polyethylene, and acrylic ester. I used 3 species of phytoplankton: a diatom, a coccolithophore, and a chromist, which are just bigger fancy names. It's similar to saying a pine tree, a bush, a plant.
Right.
So they're all different, but all the same within the same group. They're all plants. And then 3 different concentrations, just a low, medium, and high. And what I want you to take away from this is just that I used 3 plastics, 3 species, and 3 concentrations. And so for my first question, does the concentration matter? So I used 1 species, which its name is Phaeodactylum micronutum, and I used microbeads from polystyrene. And polystyrene is what is found in, or is what is used to make plastic cups.
Okay.
So every time you drink out of a plastic cup, that's polystyrene. And so I didn't use big cups. As I mentioned, I used much smaller beads and 3 different concentrations, a low, medium, high. And so the plastics that you see in the toothpaste, I actually used bead size. They're even smaller than this. So you definitely had to use a microscope
To see it.
And then so for my second question, are different species impacted the same? Well, I used 2 other species, Rhodomonas salina, again, Chloroclysis cartier, but I used the same plastic. So 2 other species, but just with the same plastic. And again, I just wanted to see what would happen if I put the plants with the plastic, how they would be impacted.
Come on in.
And then finally, my other question was, does the type of plastic matter?
Right.
Because if you look around, you see different types of plastic. The first plastic in the other slide, this is polystyrene, so the plastic that makes up plastic cups and styrofoam cups. But I also wanted to see about polyethylene, so the plastic that's in the microbeads or in the cosmetics. So it's the same plastic that's in the toothpaste. And then also acrylic ester. A company provided me a free sample of acrylic ester, and that is the plastic that is often found in outdoor paint, such as pools, or paint that's used to paint pools. And so with that, I used just 1 species, Phaeodactylum micronutum, and 2 other species, and again, just to find out what happened. And then so, big discovery. To answer my questions, does the concentration matter? Yes. At different concentrations, we are seeing a different impact on their growth rates. And then also, does the type of plastic matter? Yes, because of the 3 different types of plastics, we are seeing very different results. And then are different species impacted the same? No. Each of those 3 species that I showed you had a different impact. So some of them were growing faster, others weren't growing any different, and some were just not growing very well at all. But the one question that comes from that is, when I was doing this experiment, it was in a very controlled setting. And so we always want to know, what about the whole phytoplankton community, because there's thousands of species. And then at any one given place or time, what does it really look like in the ocean, and what's really happening? And then also, what about the entire food web? How is this impacting all the animals and even ourselves? And so with that, I'm going to play a little video. have right here is a small animal called a copepod. And it uses its legs to create a water current so that it can suck in food. And the green dots are actually microplastics that have been given a fluorescence so that we can see it. And what you're watching right here is the microbeads going actually through the digestive tract of that small animal. Okay, and you can see it right, all the green is the microplastic inside the digestive tract of these small animals. And so that's just a video showing a similar project at the zooplankton level. So I was working at phytoplankton, which means little plants. Zooplankton means little animals that float in the ocean. Another intern earlier in January, Brian Kim, with senior research scientist David Fields, they did a study looking at microplastics when ingested by these small little animals, using actually one of the same species of phytoplankton that I used, which I just happen to have here with me today. I was given a nice culture to take home.
That was a sampling?
Yeah. So this the single-celled species is actually what's making up this pink water right here. And one drop, just to give you an idea of the size difference, one drop of this liquid contains at least 1 million cells. So 1 million of these guys. And so in this experiment, this species, these little cells, the real food, this is real food that all these little animals eat, were mixed with microbeads, so plastic that's similar to the toothpaste. And they wanted to see what would happen if you put plastic and real food in and you put these little animals. And what they discovered was the animals eat the same amount of microplastics as they do real food. So that means they don't really differentiate, they don't spit out the plastic, they just, suck it in like a vacuum cleaner. And so just to give you an idea of how big these animals are, going back to that penny reference where the length of the word liberty is 5 millimeters long, the length of the letters LI is 1 millimeter, and 1 millimeter is the size of this entire animal.
Wow.
So every time you look at a penny, the LI, there's animals that small. And so from their experiment, they were able to use that experience to find out another answer to another question. What happens to the fecal pellets when these animals are eating food mixed with microplastics? And what they found was, so here's my phytoplankton, the real food, and here's the microbeads, so the fecal pellets with the plastic. And they found that it floats slower, but the real food floats or sinks faster. And believe it or not, there's a lot of animals that depend on the fecal pellet as a food source. So one of the questions from this is what's going to happen to the other animals that depend on this as a food source if it's sinking slower than it's used to. And just to show you, here's pictures. This is a normal real food fecal pellet. And you can see the microplastics, fluorescence, and green. And then so why do we care? Because ultimately what's impacting our plants, our little plants, and the primary consumers, so those little animals, it's going to ultimately impact the entire ocean food web as well as ourselves too. And then so from those two examples of experiments, more questions come up. And what I want you to take away from this is when you start searching for the answer to one question, all of a sudden there's more questions. And then you discover there's more questions. And then you discover there's even more questions. And then when you think you're about there, you discover there's even more questions and more questions and more
Before you
questions.
dig it some more.
Yeah. But just to give you a quick idea of how much plastic's entering the ocean, 5 grocery bags. So 5 of our nice Wawa grocery bags per foot of shoreline. So 5 per foot are estimated to have entered the ocean in 1 year, and that was well, 2010 was the year that they studied. So 5 of these, and 8 trillion, so this many number of zeros after the 8, is the number of microbeads estimated to enter the waters in the United States daily. So we're starting to become more and more aware and getting better, accurate accounts of just how much plastic is in the ocean and is entering the ocean. But going for our small sizes, the challenges for recovery. So we're seeing that microplastics are entering the ocean. They're not necessarily a good thing, but they're very small. So automatically just trying to find them is sometimes a challenge. And then also we're discovering that they're throughout the entire water column. So we're seeing them at the surface, we're seeing them at the bottom, and we're seeing them everywhere in between. And then one of the biggest, I think, is how do you take out these small plastics without taking out the little animals that are in the same water with them? It becomes a real problem because if you take one toe, like a net, and try to scoop out the plastic, you're also taking out all those animals and plants. But what can we do? There's several things that we can do right off the top. One, we can recognize the benefits of plastic. Plastics have made modern living wonderful. Just our cell phones alone use a lot of plastic, and so we shouldn't hate plastic, but we should recognize its benefits. We just don't want it in the wrong places. And then next thing that we can do is we can reduce, reuse, recycle, and refuse. So we can reduce the amount of plastic that we're using. We can use real silverware or cutlery rather than plastic forks. But even if we use the plastic spoons, plastic cups, we can reuse them instead of just throwing them away. We can recycle. So we have recycle bins in Vineland, and so we can take advantage of that. And then also refuse. If you have one item that you're picking up from the grocery store, do you really need a plastic bag to carry it out with, or can you just fold it? So it's making some choices like that. And then also, I've started developing the habit of the cloth bags instead of plastic bags.
Keep them in a cart.
Right. So just, we can start cutting down. And then also check the labels on your personal care products. As you see, I passed around the toothpaste with polyethylene. This is the word that you want to watch out for, polyethylene. You want to avoid, that's plastic. And then finally, we can participate in beach cleanups, or when you're out and about, if you go to the park and you see plastics, put on a glove, or use something, don't pick it up necessarily with your bare hand, and just not only look for the big plastics, but even like some of the smaller plastics that have been broken up. So there is a lot of things that we can do to at least help minimize or mitigate our contribution of putting plastic into the ocean. But just to give you more good news, there's already companies that are taking a proactive step of getting plastics out of their personal care products, as well as New Jersey has already started to make legislation on getting rid of some of the plastics in our products. And then even at the federal level, different steps are being taken to get the plastics out of our cosmetics. Yeah. And then so going back to the question that my mentor needed to look at, is there an impact of the microplastics on the marine microbial food web? Yes, we're seeing that there is an impact, but just how much microplastic and nanoplastics are we ingesting when we eat seafood, which was her original question, well, that we're still exploring. We're still working on more concise and better techniques to actually giving real results rather than just guessing at it. But if you are concerned and you eat seafood, I highly recommend going to the State of New Jersey Department of Environmental Protection website. On this website, they do list and show you which foods are safe to eat, which ones you should stay away from, and they keep it pretty updated. They update it quite frequently. And so that's, I'll give you some of the good pictures behind the scenes. So just to give you a little bit of background, so here I am. I was one of 22 interns that were invited to go to Bigelow to do summer research. And just to show you the difference, if you go to New Jersey's beach, these are what the beaches in Booth Bay, Maine look like. Very rocky, very little sand. And they love lobster. Oh my goodness. If you like lobster, I highly recommend going to Maine because they put lobster in everything.
Wow.
And then here's the house that I stayed at. The one thing I learned was one bathroom for 6 people. If I can help it, I never want to be put back in that situation again. And then the nice part was even Gary was able to come up and visit me. And I didn't get to see a real moose, but we did
And you
see.
stood there for the moose.
How was that conversation?
I almost butt him in the head.
Who are you?
And then at the lab, it was really a really neat experience. Here's a lab from the back side. It was a really gorgeous facility. I got to learn how to use new technology and try different things. Yeah, here's me at my lab bench. And then just some of the equipment, it was awesome. This is a light meter that I got to use. And here's another machine that counts the cells. And here's some of my cultures growing. And then here's me at my lab desk, or lab space. And then here's the incubator. So as I was growing, this is what it looks like, growing the cultures, my phytoplankton in the flask in the incubator. And then at the end of this experience, we had to do what's called a poster presentation. And so here's me standing in front of my poster as that day for 2 hours straight, anybody walking by, and there was a lot of people walking by. And
Speak to it.
yep, had to tell them our project, had to tell them our results. And so I did bring my poster with me. And then here's my wonderful mentor, Patricia Matrai, who helped guide me through this process. And she was absolutely wonderful. And here's just a list. It was because of the National Science Foundation that funded me to go out there. Bigelow Laboratories that allowed me to be there. And here's the list of all the wonderful people who helped me with this experience and the experiment. And I have to give a shout out to my professor at Stockton University, because if it wasn't for him, Alex Benjamin, I would have not found out about Bigelow Laboratories. And with that, I'd also like to thank everyone who's here for your support and your prayers and your encouragement. With that, thank you.
Question?
You went to the Olympics, girl.
Yeah.
Got your medal. You did a very good job.
Thank
Proud of you.
Thank you.
Yeah.
Question.
The gentleman here that